Hello there, Mr. Sutton here with the IM377 Extra Practice Number 1 Solutions on Law of Cosines. On this problem, we've got side, angle, side going on, and we're looking for a third side. Since it's not a right triangle, we're just going to go ahead and use the law of cosines in this situation. So we're going to use the one that says c squared equals a squared plus b squared minus 2ab times the cosine of c. So for c squared, we've got x squared. And then a and b are our two sides that they gave us. So 15 squared plus 27 squared minus 15 times 27, or times 2 times 15 times 27. Don't forget the 2 there. And then we have cosine of our angle, 130. Let's use the calculator to simplify the right side before we square root. So entering all that stuff on the right side in the calculator, pressing enter, I end up with 1474.7 if I were to round it off. Or 0.66, whatever. Let me just round it off. There we go. But anyway, it doesn't really matter because I'm not done. This is what x squared equals. To get x, I have to go back to my calculator, and let me just do square root, arrow up to get my output from before, and pressing enter and putting that in there, pressing enter again, I end up with 38.4. For this one, we're missing an angle, and we have a side, side, side situation in a non-right triangle. So this is a law of cosine situation. We'll use the one that says cosine of c equals a squared plus b squared minus c squared over 2ab. So we've got cosine of x then equaling big fraction. The c value in this case, which is going to always be across from the angle you want, that's going to be the 25.8. And then a and b are the other two sides, 11.4 and 17.1. So putting those in, we can write 11.4 squared plus 17.1 squared minus the 25.8 squared, the c squared there. And we're dividing that by 2 times the 11.4 times the 17.1. Let's let the calculator crunch the numbers on the right side for this one. So plugging all that stuff on the right side in using my alpha y equals fancy fraction form, that comes out to, well, it's not a fraction. They couldn't actually simplify it. But that's okay. We'll just write out the crazy decimal. Now, I'm going to keep the true value on my calculator, but when I round it off here, just in case somebody wants to actually use the rounded off value on the next step, I would take it out to 3 decimals because inverse cosine, which we're about to do, is a very sensitive function. So we've got a negative 0.624 if I round that off to at least 3 decimals. But now, again, I only have the cosine of x. To get x itself, I need inverse cosine of this. So going back here, let me do second cosine, arrow up to grab that crazy decimal. I'll just grab the whole thing so I'm as accurate as possible. Close the parentheses, press enter, and that's 128.6 degrees. For this one, we have side, angle, side, and we're looking for the opposite side from the angle, not a right triangle. So we're going to use the law of cosines, the one that says c squared equals a squared plus b squared minus 2ab cosine c. So we've got x squared then, and then a and b are our two sides that they gave us. So we have 16 squared plus 7.9 squared minus 2 times 16 times 7.9 times the cosine of 84.1 degrees. And let's go ahead and crunch the numbers on the right side using our calculator. So plugging everything on the right side into our calculator all at once, we end up with about 292.4. That's the rounded off value anyway. So that's what x squared equals. To get x, I have to square root that, which I will do on the calculator. So let me do second and then get the square root there. And I'm going to use the full value. I can do that quickly by just arrowing up and pressing enter and then enter again to give me 17.1. On this one, since we have a side, side, side situation looking for an angle, let's go ahead and use the law of cosines. Cosine of c equals a squared plus b squared minus c squared all over 2ab. So we've got cosine of x then equaling a fraction. And then I'll pick out the c value here. That's across from the angle that we're looking for. Here's the angle we want. Here's the side across from it. So c is going to be 70, meaning a and b are going to be 20 and 60. So I've got 20 squared plus 60 squared, or vice versa. And we're going to be subtracting now 70 squared. And that's all over 2 times 20 times 60. Let's use the calculator to simplify the right side now. So putting all that into my alpha y equals n over d fancy fraction mode and pressing enter, we get negative 3/8. Hey, that was nice for them to simplify that for us. But that's just what the cosine equals, is negative 3/8. To get the value of x itself, we need inverse cosine of that. So let me go back to the calculator, and then let's do second cosine, and then let me just arrow up to grab that so I don't have to rewrite it. Close the parentheses, press enter, and that's 112.0 degrees if we round off to the nearest tenth. On this problem, I want this missing angle. Since I don't have a right triangle, but I do have a side situation where I know all three sides, I'll use the law of cosines, the one that begins with cosine of c equals a squared plus b squared minus c squared all over 2ab. So I've got cosine of the x here, and that's going to be, let's see here, my c value, that's always across from the angle. Here's my angle, so across from that is 11. 11 is my c value. That means a and b are going to be 10 and 17, or vice versa. So I've got 10 squared plus 17 squared then, minus the c value of 11 squared. And that's going to be all over 2 times 10 times 17. Let's simplify the right side on the calculator. And if I just enter that into my fancy fraction mode from alpha y equals, and I press enter, that's 67 over 85. Okay, I'll take their word for it. That's what cosine of x equals. So to get x itself, let's inverse cosine that stuff on the calculator. So let me do second cosine, arrow up to grab that from before, and then close my parentheses, enter to get 37.97 and some change, so that rounds off to 38.0 if I round to the nearest tenth. To find the missing angle on this problem, since I know all three sides of the triangle, I can use the law of cosines. So I've got cosine of c equals a squared plus b squared minus c squared all over 2ab. So then I've got cosine of x, because that's the angle I'm looking for, big fraction, and then I'm going to pick out my c value first. That's always across from the angle that I'm looking for, so it's this 14 side, that's my c value. And then the legs of the angle are the a and the b, so 13 and 24. So I can write 13 squared plus 24 squared, a squared plus b squared, minus my c value of 14 squared, all over 2 times 13 times 24. Let's simplify that right side on the calculator. So plugging all that in with my fancy fraction from alpha y equals, pressing enter, that's 183 over 208. That's what cosine of x equals, just kind of a little halfway step. But I'm not quite done. I'm going to inverse cosine that on my calculator. So let me do second cosine, arrow up to grab that output, and then close the parentheses if you want, enter again. We get 28.4, and that's degrees because that was an angle.